So today we're learning the last new section, and we'll practice next week. This is called implicit differentiation. You might remember from pre-calculus when we had things like that were y equals x squared plus 5. This was an explicit form of an equation. And if we had things like this is an implicit form of an equation. The explicit form is immediately able to be put into the calculator. We're able to graph it. We know stuff about it. We know exactly what y equals in terms of x. The other one, it's still helpful, but if I wanted to put it in the calculator, I've got to solve it for y first. So it's not as immediately useful. And so far this year, except for the related rates questions, those word problems, everything we've taken a derivative of has been y equals this or f of x equals this. They've all been solved for y. So now we're going to learn how to take the derivative of things that aren't solved for y. And we'll do implicit differentiation. So implicit differentiation lets us take the derivative of implicit functions. So they're not in y equals form. And there are some steps that we'll follow. The first thing we'll do is differentiate both sides of the equation with respect to x. And WRT means with respect to. And then we're going to collect all the dy dx terms on the left and all the non-dy dx terms on the right, or vice versa. Next, we'll factor dy dx out. And last, we will solve for dy dx. So we'll do an example to illustrate this. Let's start out with, first off, let's just start out with x cubed equals 3x squared. If we wanted to take the derivative of this with respect to x, no. Let me start out differently. Let's talk about how we take the derivative of x cubed with respect to x. So this with respect to x stuff just means we're taking the derivative of something, and the variable that we are focused on is x. So in this case, what we're taking the derivative of is an x variable, and we're taking it with respect to x, so the x's match. So we just do the derivative like normal and move on because the variable's matched. This next one, let's call that a. The next one is the derivative of y cubed with respect to x. Well, we're going to do the derivative of y cubed like normal and get 3y squared. But since our variables do not match, we have to let them know that they don't match by doing dy dx, multiplying by dy dx at the end. So variables don't match. So it's like you're saying, hey, I took the derivative of this and I got 3y squared, but my variables didn't match, so times dy dx. Another one, C part. Let's do the derivative of x plus 3y with respect to x. Well, it's kind of like, which we won't do this, but it's, you remember how we would take the limit of different pieces, we'd break it up, or we'd do the derivative of different pieces. Well, we're going to do the derivative of the first term with respect to x plus the derivative, of the second term with respect to x. But we're probably not going to rewrite it this way, but we're just emphasizing what we're doing. So this first derivative, they match. So we just do the derivative of x like normal and get a 1 and move on. But the second term, y, does not match with the x that we're taking it with respect to. So we do the derivative of 3y like normal, but because they didn't match, we tack on a dy dx. Okie dokie. Let's do a full-on implicit differentiation problem. Let's find dy dx. Given that y cubed plus y squared minus 5y minus x squared equals -4. Wow, that is 1, 2, 3, 4, 5 terms. Well, we're going to do the derivative of every single term with respect to x. So I'm probably not going to write it this way very often, but we are doing the derivative of both sides with respect to x. But I'm probably not going to write that. So when you go to the y cubed, you do the derivative is 3y squared, but it's not an x, so you say dy dx. Plus, now we'll do the derivative of y squared. It's 2y, but that's not an x, so we say dy dx. Minus, do the derivative of 5y and get 5, but y isn't x, so we do dy dx. Minus, do the derivative of x squared and get 2x. X does match with x, so move on. Equals, do the derivative of -4 and get 0, because it's a constant. Okay, so we did the derivative of every term. Second step said, collect the dy dx terms on the left, put the non-dy dx terms on the right. So we've got these three here on the left, but this one needs to go to the other side. So we have 3y squared dy dx plus 2y dy dx minus 5 dy dx equals positive 2x. So we have to add it to move it over. Third step said factor dy dx out of every term. I'm just going to do it up here so we can stay on the same screen. So all three of these terms have a dy dx in them, so we can factor it out. And that would leave 3y squared plus 2y minus 5 equal to our 2x. The last step said get it by itself, solve for dy dx. So we just need to divide by this on both sides. And that gets it out of this side and divide over here. So dy dx equals 2x over 3y squared plus 2y minus 5. And that is your answer. That is finding your derivative implicitly. Okay, let's see if we can do another one. let's do 2x squared plus 8y equals 3y to the fourth minus 7. Let's find dy dx implicitly. Well, first step is take the derivative of every term of both sides. So derivative of 2x squared is 4x. X matches, so we go on. The derivative of 8y is 8. Y is not matching with x, so we put dy dx with it. Derivative of 3y to the fourth is 12y to the third. Y doesn't match, so we put dy dx. Derivative of negative 7 is 0. Second step, put dy dx on the left. Everyone that's not dy dx on the right. So we're just going to move some things around. This is going to need to go to the other side, and this is going to need to come over here. So I'm going to have negative 12y cubed dy dx plus the 8 dy dx. It's on the right side, the correct side to begin with, and negative 4x. So just change their signs as you move them back and forth. Third step, factor out dy dx. You get negative 12y cubed plus 8 equals negative 4x. Last step, divide to get the dy dx by itself. So dy dx is negative 4x over negative 12y cubed plus 8. All of these terms are divisible by 4 or a negative 4. I'm going to divide them all by a negative 4. So I'll get x over 3y cubed minus 2. All right, I would love it if you would just try number 1 on page 145. If you feel good about it, try number 3. I would love it if you would try number 1 on page 145. If you feel good about it, try number 3.